Unit 4, Section 4.5, Conditional Probabilities. So we've kind of been looking at the rules of probability. We talked about mutually exclusive and how to use two-way tables. Today we're going to look at conditional probabilities, continuing with that idea of two-way tables. So a conditional probability is the probability that an event will occur given that a related event has already occurred. For example, the probability that event B will happen given that event A has already happened is denoted by P, probability, of B given A. So this is pronounced B given A. And so the rules here say, okay, so we're trying to figure out the question of what's the probability of B knowing A's already happened. Well, what we want to do is we want to take the probability of A and B divided by the probability of all the A outcomes, because we're already saying A is what has occurred. So that's why it becomes the denominator. If I had said, what's the probability of C given D had happened? Well, that means I want to check out the probability of C and D happening out of the probability that D has already occurred. So what's the probability of them happening out of the probability of D here? And so who has pure steers is this our example. Given here are the data of 178 college statistics class of gender, so we have male and female, and whether the student has at least one pure steer. So we've looked at this result before. Find the following conditional probabilities. So this says, what's the probability I would choose a male given they have a pure steer? So this would be the probability of male and pure steer, so I'm just going to use E, out of the probability of getting a pure steer. And so if I look at this, the probability that it's male and pierced is 19 out of 178. So I would do 19 out of 178, and I'm going to kind of move that up actually. That way I already have my division. So I'm going to do 19 out of 178 here, divided by what's the probability that they have an ear pierced in general. That's 103 out of 178. And so when I simplify this, the 178s, when I take this and I don't want to divide by a fraction, this is algebraically where I would multiply by the reciprocal. So I would end up taking this 103 and flipping it to the bottom here. The 178s cancel, leaving me with 19 out of 103. These two numbers are what we're using here. No longer are we using the overall total. We're using that total of the given pure steer. So notice that I'm using the 103 as what became my denominator. So this is the formal way to write it out. If we have a two-way table, we're changing the denominator. So watch this one. Now if I switch it and I say, okay, what's the probability that I would choose somebody that has a pure steer given their male? So this is changing my denominator. This is saying that now we have only the males that we're looking at. So we're only looking at 90 people. So we've eliminated this group of people together. So of those 90 males, what's the probability I would pick somebody that has a pure steer? Well, there's 19 that have a pure steer. So now I would have 19 out of 90. If we look at the probability definition, pure steer would be 103. So this would be pure steer and male would be 19, out of 178, divided by probability of all male. This would be the 90 out of 178. And again, we don't like complex fractions, so we would switch this to multiply, 178 out of 90. Those cancel out, and we're left with 19 over 90, which is what we had here. On the third part, now we're switching gears and saying, what's the probability I would choose somebody that's female given they have a pure steer? So female, given they have a pure steer, so this would be female total only. Okay? So then I would be looking at pure steer only. And so if I start looking at that, my denominator is going to end up being the pierced ear. So I'd have 103 And what's the probability of those people that have a pierced ear that they're female? 84 out of 103. On our last one here, it says, what's the probability we would pick somebody that has a pierced ear given that they're female? So again, here's our denominator of all the females. So now we would look at people only in the female category, so 88 here. And what's the probability I would pick one of those that had a pierced ear? 84 out of 88. So we have a formal definition that we will use as we continue in our probability units, but right now it's starting out as the kind of using our two-way table to help us out. On our example here, we're bringing back the Diamondbacks example. So it says in 2012, fans at Arizona Diamondbacks home games would win 3 free tacos from Taco Bell if the Diamondbacks scored 6 or more runs. In the 2012 season, the Diamondbacks won 41 of their 81 games and gave away free tacos in 30 of their 81 games. In 26 of the games, the Diamondbacks won and gave away free tacos. Let W be a win and let T be the free tacos. So if we chose a Diamondbacks game at random, can we answer the following questions? The first thing we want to do is organize our data. Can we summarize these in a two-way table? So we're looking at wins versus loss. We're looking at tacos and no free tacos. So I'm just going to put NT. And so then we have our totals here at the bottom. So as I fill these in, looking back at the data, it says they won 41 of their 81 games. So that's a total. And they told us the overall games they played was 81. That tells us that they lost 40 of those 81 games. They gave away free tacos in 30 of their 81 home games. All right, so free tacos happened 30 times, which means no free tacos, sad day, 51 times. In 26 of the games, the Diamondbacks won and gave away free tacos. So this would be 26 here. There were 4 games where they did get 6 or more and still ended up losing. So there's our total here. And then going each direction, this would be a sad game to attend. There were 36 games where they lost and had no tacos. And then if we look here, there are 15 games where they won, but not by 6 or more runs, or didn't score 6 or more runs. So now we've filled in our table here. We can ask our probability questions, answer them here. Find the probability that the Diamondbacks win or there are free tacos. Okay, so probability that they win, or, so I can use my symbol or I can use the word, there were free tacos. All right, so when I do this, by definition, our ors, we're going to say this is the probability of a win plus a probability of a taco minus any overlap. So we could check to see if these are mutually exclusive. So can you win and get tacos at the same time? Yes. So this is going to be a number here. So probability of a win is got ahead of myself, is 41 out of 81, plus probability of tacos is 30 out of 81, minus the probability that they won and got tacos. So those are the people that we counted twice. So we counted the 41 here and we counted the 30 here, double counting 26, which is why we subtract. When I add those up, so I get 51 minus 26 there. Oops, sorry, that's a 41. So 41 plus 30 is 71 minus 26. I get 45 out of 81. And so the probability that the Diamondbacks win or there are free tacos is 45 out of 81, which is about a 56% chance. So there's a 56% chance that you would go to the Arizona Diamondbacks and you would either see a win or you would end up with free tacos. So on the second one, it says find the probability that the Diamondbacks win given that there are free tacos. This is our new conditional probability. Okay, it's asking what's the probability we get a win given that we had free tacos. So we're changing our denominator here. If we did by definition, what's the probability of a win and free tacos? out of the probability of just tacos. So we already found that these are not mutually exclusive, so they do have outcomes in common. There were 45 games. Oops, sorry. There are 26 games. I'm looking at the wrong value here. 26 out of the 81 that they had won and got free tacos, out of the 30 out of 81 that they had just free tacos. So now when I look at our simplifying here, those 81s cancel out, and I'm left with 26 out of 30 games. So knowing that there were free tacos, notice that's our denominator here. What's the probability that they won? 26 out of 30. So while organizing our data helps us see those conditional probabilities, the rule still works as well. So on our last one, it says find the probability that there are free tacos. So probability of tacos given that, so that's our new formula, they're winning. So if we know they won, what's the probability that they got tacos? So again, we can find that probability, tacos and a win, and then the probability out of wins. So if we look at probability of tacos and wins, that's still going to be our 26 out of 81. Divided by probability of a win is 41 out of 81. Denominators cancel out as we cross multiply, and we're left with 26 out of 41. So on this one, if there were free tacos, there was an 87% chance that you went to a game that was a winning game. On this one, we know that the Diamondbacks won, so if you know that they won, there was about a 63% chance that you were going to see a win and get those free tacos. Let me know if you have questions on conditional probabilities. We'll kind of keep practicing that in our activity on the next day. And so we'll just keep moving here with using our formalized formulas, as well as seeing the kind of overlap in our two-way table.